It is only true when the two are true. Look at PQ. These are the outcome of something happening. A two statement can be true. One can be true, one can be false. One can be false, one can be true, or both can be false. But in and, the two must agree. The two of them must speak the truth before it is true. So when two of them are speaking the truth, what happened here is true. What is true, false? What is true, false? False. What is false, true? What is false, false? Because the two of them must agree to speak the truth before it is true. Get it? Now, for the implies, for the implies, when the antecedent, when you have a conditional statement like this symbol means a conditional statement. In logic, the starting of your statement, you have what we call the antecedents. And the ending of a logical statement of a conditional statement is called the consequence. So the law of implies, because this implies this table now. So the law states that when the antecedent is true and the consequence is false, it is false. Otherwise, it is what? True. Are you getting me? So now at this point, the antecedent is this and the consequence is this. So the antecedent here, look at this line. This one is true, this one is true. It doesn't work. Because the law doesn't tell me like that. The law states that when this place is true and this place is false, like what is happening in that column, that this place is false. When this place is true and this place is false, it is false. Accept it. Anything outside that is true. So therefore this place is what? True. This one is what? True. The only condition that can make this place to be true is when the first guy is true and the second guy is false. Because the first antecedent must report back to the consequence. So immediately the first person speaks the truth and the second person lie is accepted to be false. So when antecedent is true and the consequence is false, it is false, otherwise it is true. So that's why that place is like that. So that's the truth table. Sir? Is it? Okay, nice topic. You never that was asking true. All right. All right. What's the statement? Black don't rock. I'm not hearing you. Okay, black don't crack. Yes, there's an element of logic. The usefulness of logic in what? Okay, the usefulness of logic in mathematics. Logic has a lot of applications. Understand? Because mathematics is a study of science. Mathematics is pure science. So logic is used especially mainly in electronics, in switching circuit and relays. Are you getting me? Logic is a study of 0 and 1s, zeros and 1. This computer operation, the application of it is logic. We call it logic gate. Are you getting me? So if you don't study logic, you don't even start engineering. You don't even start the world of electronics. Because most of the switching circuit now use the operation of logic. Are you getting me now? So logic is very, very necessary in engineering and in science. Another question? Yeah? Okay. So now, for example, now see, if you have a circuit like this, this is the principle of logic. Which connection is this? It's electric circuit. That is, what is it? This is a parallel, this is a circuit series, and this is a parallel connection. Are you getting me? This is the principle of the AND and the OR gates. Are you following me? The switching circuit of engineering is controlled by gates. Have you heard of 5x5 timer before? Have you heard of, which department are you? Okay. In the world of electronics, there's what they call a semiconductor device. Semiconductor device. Semiconductor, mostly they use germanium and silicon. For those devices, we have the diode, the triac, and stuff like that. Now, those things I'm mentioning to you now, they act as a switch because they have the characteristics of a semiconductor and a conductor. They fall in between a semiconductor, metal, and insulator. They have those characteristics. And now, the job of those switching circuit is to allow current to flow when we want it. Are you getting me? We don't want current to flow every time. And that circuit design is designed in such a way that we don't want the electricity to flow until we control it like resistor. We vary the output signal. Are you getting me? So now the story of logic will help us to control when we want light and when we don't want light. Like for example, you see all these traffic lights. Traffic light this is what they use to design traffic lights. When you want light to come, when you don't want light to come, they call it timer. It's a logic gate. You send a signal to that logic gate and it obeys your signal. Do you understand? So if you don't study logic, engineering doesn't exist. This is the OR. This OR that you see here. Look at this OR. In a circuit design for OR, remember what I told you, we have PQ. Now, P and Q. P or Q. True, 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 false, false, true, false, false. Now remember what I told you when I was telling you about this gate. I said that for this AND, the two must be true for it to be true. Otherwise it's what? False. Abi? But for OR, that it is only false when both are false. Can I say something like that? That everything outside this is true. That's the gate here. This one is the AND. This AND here is this one. The AND is that if this place is not joined and this place is not joined, there will be no lights. Is that clear? The two must agree before there is light. One cuts, no light. Or this one exists, this one cuts, no light. The two cuts, no light. See, one cuts, no light. This one cuts, no light. The two cut, no light. Are you getting me? So that's the principle. But now come to OR. You see, OR, this is OR gate. This is the principle. Now for the OR, you see, true, true, there's light. That's if you connect this series connection. That's why in our appliances for our house, we connect it in this kind of connection so that there will still be light. You join these two, there's still light. You remove one, there will still be light. That's you remove one, there will still be light. You remove this one, open this one, there will still be light. The only way you will not see light here is when these two guys are not on. A statement can be true. A statement in logic, a statement has what they call a truth value in logic. A truth value is either a statement is true or false. You understand what I'm talking about? So anything outside that is another topic entirely. In the context of what I'm teaching you now, a statement has a truth value. And the truth value is either the statement is true or false. So if you talk about a falsity in a statement, maybe another topic, or maybe your area of discipline, which is not what I'm telling you now. So let's follow the context of what I'm teaching you. Talk to me, I'm talking to you. In that case, what you are saying is fallacy here. All right, let's proceed. So I've been able to show you the truth value. Eh? 6 hours. What am I going to tell you? No. All right, now let's still proceed to the that's what we call the condensed truth table. Now we have the read table, we have the condensed table. In most cases, they specify the table you are using. If you're asked to prepare a table now, they say prepare the truth table for anytime you see a table that they ask you to prepare, and you see alphabet that is more than 2, like look at you have PQR, you should know that is a logic that contains 3 propositions. And you know, in logic, we are still under the subtopic of truth table. Now, if you're asked to prepare a truth table for a logic, I remember that I told about the truth table. The truth table shows the truth value of a statement, whether what that person is saying is true or false. Now, if you ask to prepare a table, you have 2 letters. No, it is a 2 proposition. But if it's 3, PQR, no, that is 3. And in a case like that, the table is not prepared the way it's prepared in 2. Because in 2, if you have P, you have Q. Then you have P or Q like that. In a 2 by 2, the statement is followed true, 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 false, false, true, and false, false. But in a case that you have 3 propositions, what to do is that when you bring your P, write your Q, need also introduce R to it. Meaning that in a 3 proposition, when you prepare your P, if you look at what is happening in this place, always 2 is to 2, 1 is to 1. That's the ratio of 2 to the power of n, where n stands for the number of propositions. So if you want to prepare a table of 2 propositions, it's going to be 2 to the power of 0, 2 to the power of 1. So the truth will be 2 is to 2, 1 is to 1. But in this case, because it's 3, 2 to the power of 3, what you now do is that it's going to be 4 is to 4, 2 is to 2, 1 is to 1. So at that point you have 1, 2, 3, 4. 1, 2, 3, 4. That is 4 is to 4.